Welcome dear student and Jai Swaminarayan. In the previous video, we will discuss the first 8 question of the exercise. So dear student, up till now you have not seen the previous video. See the previous video. In the previous video, we will discuss about the first 8 question of the exercise. Now dear student, in this video, we will discuss the remaining question answer of the exercise, right? So let us start with the exercise question number 9. Na plus has completely filled K and L cell. Explain, right? Here Na plus, that is the sodium atom, right? Na plus has completely filled K and L cell. K cell, that means the first orbit, and L cell, that means the second orbit. So Na plus has completely filled first and second orbit, right? Now explain, right? The atomic number of the sodium Na is a 11, right? We know that the atomic number of the sodium is a 11. So the neutral sodium atom has a 11 electron and 11 proton. The number of electrons in the sodium atom is a 11, right? And the number of proton in the sodium atom is a 11. So the sodium atom is a neutral, right? It has a 11 proton and the 11 electron, and its electronics configuration is 281, right? That means in the first orbit K cell 2 electrons are there, in the L cell 8 electrons are there, in both the cell is completely filled, and in the third cell M cell third orbit 1 electron is there, but Na plus has a 10 electron. So from this sodium atom, right, 1 electron in the outermost orbit are removed out of the atom, we get a K cell is completely filled and L cell is also completely filled. So it becomes the Na plus. Why? Because 1 electron is out from the third orbit, right? But Na plus has a 10 electron. Out of 10 electron, K cell contains the 2 electron and L cell contains the 8 electron. That means K cell and L cell are completely filled. So Na plus, what do you mean by the Na plus? Actually, the sodium atom has a 11 electron, but 1 electron is removed from the sodium atom, it becomes the Na plus. Plus 1, that means the 1 electron is removed. If the 2 electron is removed from the outermost orbit of the atom, it becomes a plus 2, right? So here the 1 electron is removed from the third orbit, it becomes the Na plus, and La plus has a 10 electron, in the K cell contains the 2 electron and L cell contains the 8 electron, right? Understand? Now question number 10. If bromine atom is available in the form of two isotopes, Br 3579, 49.7% of bromine atom is a Br 3579. Atomic number is a 35 and atomic mass is a 79, and 50.3% atoms of the bromine are Br 3581. So here there are two isotopes of the bromine. Bromine atom is available in the form of the two isotopes of the bromine, Br 3579 and Br 3581, right? So here 35 atomic number are same, but atomic mass is a different. Calculate the average atomic mass of the bromine atom. So here in the bromine atom, 49.7 percentage is Br 3579 and 50.3 percentage of the Br 3581. So how we can calculate the average atomic mass of the bromine atom? So 79 atomic number, 49%, 49.7% of the Br 79. So Br 79 multiply by 49%, that means the 49 divided by 100, plus Br 81, how much percentage? 50.3 percentage. So 81 multiplied by 50.3 divided by 100, right? So if we consider the 49.7 percentage of the Br 79 and 81 per, so 50.3 percentage of the Br 81. So if you calculate this, 79 multiplied by 49.7, 3926.3 divided by 100 plus 4074 into 0.3 divided by 100. 81 multiplied by 50.3, we get a 4074.3 divided by 100. So if we sum out it, 8000.6 divided by 100. So the average atomic mass of the bromine atom is a 80.006 AMU, right? So dear student, how we can calculate this average mass, right? Understand or not? So take the 79, 49.7% of the 79 atom, right, and 50.3% of the 80 BR81. We can easily calculate the average atomic mass. Similarly, dear student, a isotope is given to you. Two isotope is given to you for the any atom. You can calculate the average atomic mass, right? First, you need to take a 49.7% of this Br79, 79 multiplied by 49.7 percentage plus Br81 50.3%. So 81 multiplied by 50.3 percentage. You get the actual mass, right? Now, similarly, we take the another question number 11. The average atomic mass of the sample of an element X is 16.2 AMU. Here the average atomic mass is given to you 16.2 AMU. What are the percentage of the isotopes X816 and X818? Here the atomic number is 8 and atomic mass is a 16. So one isotope of the X is a X816 and second isotope of the X is a X818, like this, X818 and X816, right? What are the percentage of the isotopes X816 and X818, right? We need to find here the percentage of each isotope, right? But in this sentence, right, the exact reverse of this above previous example, right? Here the average atomic mass is given. In the previous example, from the percentage, we can calculate the average atomic mass. In this example, from the average atomic mass, we need to calculate the percentage, right? So here it is given that the average atomic mass of the sample of element X is a 16.2 AMU. Now, let us assume that the percentage of the isotope X818 be a Y percentage or X percentage, any, right? But here the element is X given, so we assume that the percentage of the isotope X818 be a Y percentage. So that we can say that the percentage of the X16 will be 100 minus Y percentage, right? So now, what is the formula of the average atomic mass? Here the X818 is a Y percentage. So 18 multiplied by Y percentage plus 16 multiplied by 100 minus Y percentage is equal to the average atomic mass is equal to the 16.2 AMU. So we can write like 18 multiplied by Y percentage, that means the Y divided by 100, plus 16 multiplied by 100 minus Y percentage, 100 minus Y divided by 100 is equal to 16.2. So if you multiply this, we get 18Y plus 16 multiplied by 100, 1600 minus 16Y divided by 100 is equal to 16.2. If we take the 100 other side, right, 18Y plus 1600 minus 16Y is equal to 1620, right? So 18Y minus 16Y, 2Y plus 1600 is equal to 1620. So from that we get the Y is equal to 10. So here the Y we assume that percentage of the isotope X818 is a Y percentage. So we can say that the percentage of the isotope X818 is a 10 percentage, and 100 minus 10 we get the 90. So the percentage of the isotope X816 is 100 minus 10, that is the 90 percentage, right? Now question number 12. If Z is equal to 3, what would be the valency of the element? If Z is equal to 3, that means the atomic mass of the element is equal to 3. What would be the valency of the element and also name the element, right? If the atomic mass of the element is 3, we name the element. What is the element? The element is a lithium, right? So here the element is a lithium. Now atomic mass is a 3, that means it has a number of electrons in the atom of the lithium is a 3. Now the if we consider the electron configuration of the lithium, that is in the first orbit k cell 2 electron and in the second orbit 1 electron, total 3 electrons in the lithium, right? So here the atomic number of the element is a 3, the element would be a lithium. Lithium has a 3 electrons in that atom, right? So it has the electronic configuration in the first cell k cell 2 electrons and in the second cell 1 electron is there, right? So in the lithium atom, in the outermost orbit there is only 1 electron, right? So it has a valency 1, right? So the lithium element has a valency of the element is a 1, since the outermost cell has only 1 electron and the element is with the Z is equal to 3 is a lithium, right? Now question number 30. The composition of the nuclei of two atomic species X and Y are given as under, right? The element X and element Y. Element X has the number of protons 6 and the number of neutrons 6. Element Y has the number of protons 6 and the number of neutron 8. Give the mass number of the X and Y and what is the relation between two species, right? So here the element X has the number of protons 6 and the number of neutrons 6. So what will be the mass number? The mass number of the element is the number of proton plus number of neutrons. So the mass number of the X is equal to the number of proton plus number of neutron. So in the element X, 6 proton and 6 neutron is there. So its a mass number is a 12. So the element X has the atomic number 6 and mass number 12. Now element 12, element Y. Element Y, mass number of the element Y is equal to number of proton plus number of neutron. 6 plus 8, it is equal to 14, right? So element Y has the atomic number 6, but the atomic mass is a 14. So both the element X and Y have a same atomic number 6, but the different mass number. So they are isotopes of the each other and the elements are a carbon. Carbon C612 and C614 are the two isotopes of the carbon. So here the element X and element Y have a same atomic number but the different mass number. So they are the isotopes of element and the isotopes of the carbon C612 and C614, right? Understand? Now question number 14. For the following statement, write the T for true and F for false. So write the true or false. Question number 14. First point is that J.J. Thomson proposed that the nucleus of an atom contains only nucleons, right? According to the J.J. Thomson model, given that according to the J.J. Thomson, all the positive charge is distributed over a sphere, right? So J.J. Thomson model proposed that the nucleus of an atom contains only nucleons, right? The J.J. Thomson was not proposed, it proposed by the Rutherford. So the statement is the false. Rutherford's model of an atom proposed that the nucleus of the atom contains only nucleons, proton and neutron. B. A neutron is formed by an electron and proton combining together. Therefore, it is a neutral. A neutron is formed by an electron and proton combining together. Therefore, it is neutral. This statement is a false. Why? Because in the atom proton is inside the nucleus and the electron is revolving around the nucleus. So neutron is a neutral. That means it is not formed by the electron and proton. See, the mass of the electron is about 1 divided by 2000 times that of the proton. This statement is true, right? The mass of the proton is 2000 times the mass of the electron. So the mass of the electron is 1 divided by 2000 times that of the proton. So this statement is a true. D. An isotope of the iodine is used for making a tincture iodine, which is used as a medicine, right? So isotopes of the iodine is used for making a tincture iodine, which is used as a medicine. This statement is a false. Iodine is used for the tincture iodine, but not a isotopes of the iodine. Now, question number 50 to the 18, that is like a multiple choice question, right? You have to select any one option from the given option. Question number 15, Rutherford's alpha particle scattering experiment was responsible for the discovery of blank, right? Atomic nucleus, electron, proton or neutron, right? So here we can say that according to the Rutherford's alpha particle experiment, the is responsible for the discovery of the atomic nucleus, and from the Rutherford model we can say that the sum of the alpha particle, very few alpha particles are in the backward direction. So Rutherford state that where in the inside the atom at the center the atomic nucleus is there. Question number 16. Isotopes of an element have the same physical property, different chemical properties, different number of neutrons or different atomic number. Isotopes have a same atomic number but the different atomic mass. Atomic mass is a different. That means the isotopes have a different number of the neutrons. Right? Understand? Now, number of valence electrons in the Cl minus ion. Cl minus ion. Cl minus ion. How the Cl minus ion becomes? Chlorine has a atomic number 17. If you considering a electron configuration of the chlorine, if you consider the electron configuration of the chlorine, first orbit 2 electron is there, and the second orbit 8 electron is there, and in the third orbit 7 electron is there, right? So chlorine has a atomic number 70. In the first cell 2 electron, second cell 8 electron completely filled, and in the third cell, right, 7 electron is there. So its a valency is a 8 minus 7 1, right? So chlorine atom gives the 1 electron and becomes a Cl minus ion. So if we considering a chlorine atom, right, in the outermost orbit of the chlorine atom is a 7 electron. But if you consider the Cl minus ion, Cl minus ion forms by gaining the 1 electron. So 1 electron is added in the outermost orbit. So total number of the electron in the outermost orbit is a 8 and it forms the octet. So the Cl minus ion has the 8 electrons in the outermost orbit. This question is very important, right? Cl ion, if you take the Cl number of valence electrons in the Cl atom are a 7. But if you consider the number of electrons in the Cl minus ion, it is a 8, right? Which one of the following is the correct electronics configuration of the sodium? Sodium atom. Sodium have a atomic number 11, right? Sodium has a atomic number 11. That means in the sodium atom 11 electrons are there. So it's a electronics configuration. In the first orbit 2 electron is there, in the second orbit 8 electron, and in the third orbit 1 electron is there. So correct electronics configuration of the sodium atom is a 281. Answer is a D. So now dear student, last question of the exercise, complete the following table. First one, atomic number, mass number, number of neutrons, number of protons, number of electrons is given, and the name of the atomic species. Sum of the point is given to you table. So let us start in the first row. In the first row, so let us start with the first line. In the first line, the atomic number is given to you 9. Atomic number gives the number of the proton. So the number of protons in the element is a 9, right? So we place here 9. Number atom is a electrically neutral. Number of protons and the number of electrons are same, right? So number of electrons in this element is also 9. And mass number, what is the mass number? Mass number is total number of the proton and neutron. So here the number of neutron is 10 and the number of proton is 9. So the mass number is a 19, right? So the element with the atomic number 9 and the mass number 19 is a fluorine, right? So elements with the atomic number 9 and the mass number 19 is a fluorine, right? So let us take the second line, right? Second line, the element, name of the element is given to you 16. Name of the element is a sulfur and the atomic number is a 16 and the mass number is a 30. This atomic number gives the number of proton and the number of electron. So here in this sulfur, number of proton is a 16, number of proton is a 16 and number of electron is also a 16. So write here 16, 16, and mass number gives the total number of proton and neutron. So how we can calculate the number of neutron? The number of neutron is equal to mass number minus atomic number. So 32 minus 16, again we get here 16. So the element with the 16 atomic number and 32 atomic mass is a sulfur. Now take the third line. In the third line, mass number is a 12. Mass number is a 24 and the number of proton is a 12. So here the number of proton is 12. That means its atomic number is a 12, right? So atomic number is a 12 and it has a electron 12. So 12 number of the electron, right? So here 12 electrons and 12 protons are there. Mass number is a 24. So number of neutron is 24 minus 12, that is a 12. So atomic number with the 12 and atomic mass is a 24. Which element is there? The name of the element with the atomic number 12. So the name of the element with the atomic number 12 is a magnesium. So write here the name of the element, that is a magnesium. Now fourth line, here the mass number is 2 and the number of proton is a 1. The number of proton gives the atomic number, the total number of proton is 1. So it has a atomic number 1. So write here atomic number 1. Number of electron is equal to number of proton. So write here 1, right? 1 proton and 1 electron is there. Mass number is 2, right? Mass number is 2. So the number of neutron is 2 minus number of proton. So the number of neutron is also 2 minus 1 is a 1, right? So the atomic number 1 and atomic mass is a 2. The name of the element is a deuterium. Deuterium, right? It is the one isotope of the hydrogen. Here given that the mass number 1, number of neutrons 0, at proton number of protons 1 and number of electrons is a 0. So here the number of proton gives the atomic number. So atomic number is a 1. But in this, if the element with the atomic number 1 and the mass number 1 is a hydrogen. But in this, the number of electron is 0. That means the 1 electron from the hydrogen is removed from the atom. So the name of the element is a hydrogen ion. It becomes a H plus ion. So understand, dear student, all the answer of all the question given in the exercise.